Hello, welcome to this video in which I will show you how to use voltage division to solve for the voltage across a simple circuit in series. I will also underline some concepts that we may take for granted or we may not explicitly state here, but they are very useful in order to understand how we arrive at the answer and why is the answer the way it is with positive, negative, etc. So the first thing to understand is that we will use the passive sign convention. So the passive sign convention is a way in which we can communicate the sense of direction of the current, how the voltage, whether it's positive or negative, and as long as you stick to that convention and do not deviate from that, you will always ensure that you have the correct answer. So let's say we have a resistor here with its two terminals. So in this case here, we have a plus and a minus, which is going to be the voltage. This is the resistor value. And the current, remember that, is what we call a through variable. So the current goes through the resistor while the voltage is measured across 2 points. So in this case, the current is entering the positive terminal. The passive sign convention then states that the sign of the power is going to always be positive. Likewise, in this case, if the current enters the negative terminal, in this case, we will have that the product of the power, in this case, will be negative. Or we can also assume that the voltage is negative. So for voltage sources, we also need to make sure that the passive sign convention is applied. So let's say we have here a voltage source, which is plus minus. Then we will have our terminals here. We already have the terminals here determined by the polarity of the source, which is plus minus. Since sources deliver power, resistors consume power, right? Resistors are the ones that receive the power which then consume, right? Whether it's a light or a resistor in a circuit, any kind of model. So in this case, the resistor consumes power, the voltage source delivers the power. So this means that the power must be negative by the passive sign convention in sources. So in this case, the current will go from minus to plus. So this will give us a sense on how the current flows in this circuit. In this case, this is the minus, this is a plus, and thus the current will flow in a clockwise direction. This is important because we will see when we go into voltage division that the correct answer is made whether it's plus or minus. So remember the voltage division formula. So the voltage division is a canonical circuit. Canonical meaning that it's, I guess, almost like law, in which you have a circuit with two resistors and you have a voltage. And then here you have two resistors, R1 and R2. Let's say you want to take the voltage across R2. So by voltage division, we will apply the voltage, which is going to be V times the resistor we want to take the voltage from over the sum. So in this case, if we want to take the voltage across R2, it will be R2 on the top. If we want to take, let's say, the voltage across R1, then we will have to change our resistance here on the top to be R1. So that's how voltage division works. So in this case, we will apply the formula. We know that this V naught is telling us that this is going to be plus minus for the result. However, notice that since the current flows clockwise, we will have the current entering the negative terminal. In this case, then, the voltage will be negative because it's entering the negative terminal that the answer asks us where with the polarity of the voltage. So then our voltage V out is going to be minus, and then the voltage, which is 3 volts, times the resistor we want to take the voltage from over 3 over the sum, right? So in this case, it's going to be minus 3 times 3 over 3 plus 6. So it's 3 over 9 times 3. This is equal to negative 1. So negative 1 volt. Why? Because of the passive sign convention. So now it's time to take our result here, put negative 1, then submit, and then we have the correct answer. Now, let me show you a similar problem in which it may have different polarity. So negative, negative. Okay, there's one. So in this case, we have remember, from passive sign convention, this is minus, this is plus, so the current here now flows counterclockwise. And we want to take the voltage from the 9 ohm resistor. And notice here that the voltage output, the terminals are plus and minus. So the problem asks us to, based on this polarity, get the output or the result. So VO then is going to be positive 6 times, and then the resistor we want to take the voltage from, over the sum. So it's 5 plus 9. So then the answer here will be equal to 9 over 14 times 6. So this will be 3.857 volts. So three decimal places, I think that's good enough. And notice here that we don't need to put a minus. Why? Because of the passive sign convention. Enters the positive terminal. So now we're going to have that the voltage here is 3.857. We will submit, and the problem is correct. So hopefully this video helped you in understanding a little bit more about voltage division and some of the underlying concepts that at first we might not be aware of. But hopefully, yeah, this helped you. If you have any questions or comments, please let me know. And thank you for watching. Keep practicing.